In the previous video, we saw how multi-tenant's technical efficiencies can directly reduce the number of CPU cores required to process a database workload. In this video, we turn our attention to memory efficiencies. Similar considerations apply to memory efficiencies as do to CPU efficiencies. In other words, consolidation math is also useful for understanding how multi-tenant reduces memory pressure. However, there is far more to this than simply the need to buy less memory. The key point is that by reducing memory pressure, multi-tenant allows for far better CPU utilization. Indirectly, it has a very important implication for reducing CPU requirements. Let's explore this in some detail. First, let's consider a development and testing use case. Given that 70% or more of most customers' databases are for dev and test, this is a very important use case. The typical model is for each developer to have one or perhaps a few databases each, to isolate their work from other team members. Before multi-tenant, each of these databases would probably have been provisioned in a VM. The answer to the important question, how many workloads can I support on this server, depends on the scarcest resource. Dev and test tends to be light in terms of CPU consumption. There's a lot of think time and not much processing time. However, there's a significant memory footprint to a VM running a database, any database. That's the main point to remember here. A typical metric is 6 GB per VM. You might get away with 4 gigs, but it wouldn't be much fun. For our example, we'll think about a common commodity server with 96 gigs of memory. 6 times 16 equals 96. This means that if you provision your databases in VMs, you can support up to 16 databases there. Even if the CPU load is low, for more databases, you'll need a new server because you've run out of memory. If you think about it, that really hurts. You're paying for your software based on CPU cores. You're only burning them at 30%, and already you need to buy licenses for more of them. That's a bad deal. Here's a better one. Replace that legacy cloud infrastructure based on VMs with Oracle Multitenant. Now, in the very same server, deploy a single multi-tenant container database or CDB. In this model, bulky VMs are replaced by nimble, pluggable databases or PDBs. There's a single set of infrastructure at the CDB level, rather than heavy infrastructure replicated in each VM. The intrinsic memory and CPU footprint of a PDB is negligible. You only require resources for the productive workload of each PDB. Therefore, at these low loads, it would be easy to support many times more developers in the same server. This is a great example of the memory efficiencies of a cloud model powered by multi-tenant. So now we return to the test drive that we saw in the introductory video. This time, we'll walk through it in a play-by-play style. Glancing at the dashboard, the dial on the left shows fuel, that is, budget, in the left gauge, and servers in the right one. The central tachometer shows number of databases, with counters for capital expense and operating expense. On the right, we have gauges for CPU load and memory pressure. Starting with the VM model, we'll buy a server and licenses for the software running on it. Our server count goes up, and we take a bite out of our budget. We start to put some miles on our capital expense counter. And as we set the server up, we start to spend some OpEx dollars too. As we begin to provision databases, we see the CPU and memory loads increase, but not at the same rate. We max out the memory before the CPU is significantly loaded. But at this stage, we're out of capacity. Our scarcest resource is fully consumed. We're going to have to dig back into our budget to buy another server and licenses for a whole new set of cores before we can get back on the road again to provision more databases. Again, we run out of memory before CPU and repeat the process. It's a rough ride, as you can see. Personally, I'd prefer a smoother ride. With the multi-tenant model, our initial costs are comparable. We still have to purchase a server and software licenses for all its cores. And now we're off to the races. Notice how the consumption, in terms of memory per database, is far lower. The lower memory pressure allows the CPU to be revved up to a far more efficient load. The result is a far smoother drive, reaching our desired destination, that is, database count, in a single vehicle or server. It's pretty clear which model is the winner. By far, multi-tenant represents both the smoothest drive and the lowest cost. Again, the key point is that by reducing memory pressure, multi-tenant allows for far better CPU utilization. In turn, significantly fewer servers are required to process the same workload.